Hello and welcome. Today I'm going to show you how to build your first rug with Python and Langchain. We are going to use an example of a PDF of a plumbing services business, and we are going to take this PDF, we're going to chat with it, ask questions. We will be able to load PDFs, text files, whatever files you want. We can then later take this knowledge base and we can turn it into a chatbot that can sit on a website, on Telegram, on WhatsApp, whatever it is, sell services 24/7 and just save you tons of time while you are not there. So we're gonna start with a bit of a quick overview, then we're gonna dive into the code and I'll show you step by step how you can build this. The skills that are gonna be talked about today is Python, Langchain. We're gonna use Chroma as a vector database, and we are also gonna build a knowledge base from scratch. And before we dive into the video, I would recommend you to watch these two videos as well. The OpenAI functions will help you understand how to turn this knowledge base into more like an agent. And also the OpenAI chatbot that we did is a simple chatbot we built for Telegram and did some AI in there as well. If you combine the knowledge base that we are gonna talk about in this video with this OpenAI chatbot, plus these OpenAI functions, you can really create a powerful AI agent for your business or for your clients. So let's start by first defining what is a RAG. The full phrase is Retrieval Augmented Generation, and all it is, it's a technique that allows us to take text files, documents, PDFs, markdown, and connect them to the LLMs and chat with them so they can process it, analyze it, and do all sorts of cool stuff with it. Instead of going to ChatGPT, which is trained on all sorts of data, we can take our own documents and ask really specific questions. And it's also much cheaper because we only get the context that is relevant to our question, so we don't need to send tons of tokens to these LLMs. We start here with documents. It can be PDFs, it can be text files, JSONs, whatever it is. Then we want to divide them to chunks. So the whole idea is that we don't want to get the whole document, the whole context. We want to divide it to separate parts. And here it really depends on your data, what you want to accomplish here. For example, I have this project that I'm working on right now that we have a JSON with full of items and so on. And we want to retrieve the most relevant JSONs. In this case, we are just separating those to each JSON item in the list and just give me the JSON items that are relevant. Once we split them, we are gonna use an embedding function. So what is really an embedding? What's the process of embedding? So in order for our LLMs to analyze our data, we need to turn these into numbers so they can do some calculations and run algorithms around this. So the process of embedding is basically we take our documents, we take our chunks that we created, we get them through an embedding model, and in the end we get a vector full of numbers that is representing our text. And this embedding model can come from OpenAI, Claude, Bedrock, all sorts of providers. And the more quality or the more powerful and the more smart the embedding model is, the better it will be able to embed this and give us a better context. So once we take our text and turn it into vectors, which is essentially numbers, we go and store it on a vector store. So we are mapping all our data from text to numbers. So next to what's happening is we have a user query. It can be a question, it can be whatever it is. And we also embed the user query as well. So we also get a vector full of numbers from this as well. What we then do is we take this vector, we take the vector store and we get a retriever out of this, which it's simply, we choose what type of search similarity we want to make. So we take the user query and we send it to the retriever. And what the retriever is doing is it's using a search algorithm that it's trying to find which vectors have the closest distance or the closest distance in terms of context and meaning. And then it gives us our relevant context. This similarity is happening with mathematics calculations, like if you learn some linear algebra and so on, you have the dot product, you have all these things to calculate the distance between vectors in the space. And really what's happening in the background is it's finding the distance that is closest to your query in our vector database, in our vector store, and it can apply all sorts of distance-based algorithms like Euclidean distance, cosine similarity. We can then connect it to an LLM, so just give it a prompt, tell it, okay, this is the context, answer the question. In the example of this video, we are just doing a Q&A knowledge base. So we just asking a question, give me the answer. You can also give it different instructions, analyze this data, process it, structure it, do something with this data. So I have this document about plumbing services, and it's actually about all the company, the pricing structure, everything we need to know about the company. Now, if I run this command, build vector with clear flag, what we see is that there was 0 existing documents in the database and we added 5 new documents. And now we can query this. Then if I run this main py file, it was asking what type of fixes do you do, and then it pulled it from the document. Pretty cool. So now let's get into the actual build. So the first thing we need to do is we need to activate our virtual environment. It's already done. I'm using PyCharm. We need to install the requirements. If we'll take a look at what we have here, these are the ones that we are using. We are using Langchain, OpenAI, Chroma DB, and this is for reading PDFs. And this is to load our .env file. To actually make this work, we install it, and then you want to create a .environment file and you put your OpenAI API key. We have these 2 lines that is essentially gonna load the parameter of OpenAI key to your environment variables. So we can then use it like this and send it to our LLMs. This one is building our database and this one is querying the database. We start here on the documents and we want to turn them into chunks. Then we want to embed them. Then we want to store them. Okay, so I'm using this library from Langchain, and all we do is we take the documents path, which is set in the settings. It's located in resources under documents. So if we go here, these are all the documents that we have. It means that every document that we got on this folder is gonna be loaded and is gonna be inside our vector store. This one is returning us a list of documents, and we start in this function. Once we get this list of documents, we move it to the chunk documents function. It's splitting these documents into chunks. This is another function from Langchain that is saving us some time. So you have all sorts of different types of splitters. We are using the recursive character text splitter. It makes sure that it's splitting related pieces of text. So we give it the chunk size, how many length, how many characters we want in each chunk. We want 1000, and what's the chunk overlap. Once we created the splitter, we send it the documents that we loaded from this function and we get it back here. This is the chunks we got. You see that we have page 0, page 0, page 1, page 1. So we got 5 chunks for 3 pages. Now the next thing we want to do is we want to structure our chunks. So what we are doing here is we just implement a way to give it an ID. The ID is, you can imagine, like a simple database. You want to be able to get objects using the ID. You want to be able to update your chunks. You want to be able to have some kind of a unique identifier. And this is what we are actually doing here. It's just counting the index based on the source. So each time we have a new source, we just give the chunk index 0. So in the end, if we'll take a look at the chunks, what's happening, now we get the document itself, but also we are adding metadata to the file. And if we take a look at the metadata, and we have the ID. So the ID is 00, 0. So we have these 5 chunks, and this is the unique IDs of each one of them. So 0, 1, 2, 3, 4. Once we get our processed chunks, we send the chunks that we created, including the content and the metadata inside of them, and we give them the unique IDs. Now let's take a look at the data object, which is, as we can see, it's a Chroma DB object. What is Chroma? It's a unique database that allows us to store vectors, which is different than MySQL and so on. And if you are looking at their site, you'll see that you can store documents and you can also store their embeddings, and you can query this database. And this database specifically is local. And towards the end of the video, I will talk about how you can use this in production as well. We'll take a look at our main function here. What I'm doing here is I'm getting this Chroma DB from this function. So because we are using this Chroma DB, I created here a singleton. If you'll take a look, we are using it in the build vector database, and we are also using it when we need to query this here, which we'll talk about in a moment. So it makes sense to make it a singleton or kind of a global or something that we can get into and set it up only once. Now, if we dive into what it's actually doing, the Chroma DB is combined with 2 parameters here. So the first one is the persist directory. This is where it will save the local database. So under the hood, Chroma is working with SQLite and is storing all our vectors in SQLite. So we don't want to embed and create our vector store every time for all the documents. So this is why we want this to persist, and we want to only create for new documents. This will save us time and money, and it really depends on how many documents you have. The process of embeddings is costing you money. For this purpose of this video, 1 PDF or 2 PDFs or a small amount of data will cost you less than $1, like 5 cents or something. And of course, it really depends on the provider. So it's getting this persist directory, where to load our database or where to save it. And it's also getting a embedding function. And in this case, we are using OpenAI, which is quality and robust. The better quality the embeddings you are choosing, the better results you're gonna get. And if we'll take a look at their integrations here, you'll see that they're integrating with a lot of like OpenAI, Gemini, Hugging Face, and so on. And this is how we create our DB instance. So essentially we get this DB instance and we send it to the update database. So all we do here is just add the documents. As I mentioned, we wanna store our vector once, and we wanna be a bit smarter about this. So if we already have the documents with the same IDs, we don't want to store them again unless they were changed. And this is how we're gonna do this. So what we are doing is we are taking all the existing documents from the DB with this simple function. We then create a map or dictionary. We then run the process chunks again, which is loading documents, creating the structure. We talked about this structure again for the same documents that are in our docs directory. And all we do here is just, we are iterating through these chunks. And if we check, we take the ID from the metadata that we store it inside of it. Then we check if this chunk ID is not in our dictionary. And if it's not, we are adding this to this array of new chunks. Then we check if we have something new to add, and we are putting this log, and then we are using again the add documents new chunks. And therefore, when we run this again, it says processing source. So this is the process, and this is the chunks it created. And it says that no documents added because we already have them inside. So this is how we build our vector store. And just to make it a useful tool, we only need to build this database once. So we can build this with the command line and just add new documents to this folder. And all it's doing here is just checking, do we want to clear this? If we want to clear, we just call the clear database. And all it's doing is taking the Chroma path from our settings and it's just deleting this folder. And then it's updating the database as well. So if I go ahead and I add another document here and we run this file again, this time without the clear, we see now our new chunks. It added 22 new documents and the database was initialized. Okay, so now let's go to querying the actual RAG and how it works. So if I ask it this question, what type of fixes you do, it gives me the answers from the document that I showed you. So let's take a look at what we do. As we've seen on this diagram, we have the vector store, we have a retriever, we have the user query, and we have an LLM. So in this case, we are using the DB get Chroma DB. This is why we did it global. And now we make it a retriever. Making it a retriever is actually like, how do I want to retrieve the data from the database? In this case, we are using a similarity search that is giving us a score with a threshold. And we also set this threshold. If we'll take a look at the actual output of what it's doing, it's taking the question and it's invoking this. So if we'll take a look at the retriever, you see that we have the same embedding function that we had in the DB because we obviously send it the DB. So we have OpenAI embedding. It then takes the question and it invokes it against this retriever. Even if we take a look at the result, we see that these documents are all the documents that are in proximity or in distance got the score 0.5 or more. The score threshold is between 0 and 1. The more it's 0, it's less similar, and the more it's close to 1, the more it's a perfect match. So it means this is the closest. And also if we'll take a look at the DB and we write your search, you see that we have all sorts of options here for similarity search, and this is what it's doing in the background. And you can take a look at the Langchain docs, and here you see a list of all the retrievers you can use. What we did is we used the simple one like this one. Now the next thing, once we have the docs that are relevant, in the LLM what we do is we just format this document. So the context looks like this. Okay, next we use this template. So we tell it simple Q&A template, answer the question based on the following context only. This is the context, this is the documents we just formatted, and this is the question. We then call the invoke, we get the result and we return it. And let's say if I ask it a different question like what is local stack, should give something like this. If I do restart, we see that, yeah, in an emulator, blah, 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 exactly got it from here. And this is what we call a RAG, like a Q&A knowledge base. Now, the cool thing about this setup is that we can also use it in production, of course, not in large scale, but if you want to do some POC or a prototype or start using some AI agent, what we can do is we can use this command to build the vector DB. And before we deploy this, we're going to build the DB. We're going to make sure that we also commit the SQLite, and then our app will always load it to memory. And if we add new documents, will just add the new documents and our app will just load the database. So that's it for this video. I hope you learned something new, and make sure that you subscribe and like, because I'm gonna make it kind of a series. So the next part in the series, we created this knowledge base. Now, how do we deploy this on the cloud and be able to use it and embed it on the website? So if you wanna know when this video is coming up, click the subscribe. And also you might want to watch this video next about Telegram chatbot that we built on the channel, simple chatbot. And you also wanna use these OpenAI functions, because then you can take this knowledge base, can turn it into a powerful Telegram chatbot. Thank you for watching, and I'll see you in the next ones.